Hello students, welcome to Narayan PU College online classes. So the next topic is hybrid. We are discussing about the hybridization. So hybridization of elements involving d orbital. Till now we have discussed hybridization involving the s and p orbital. Now we will discuss about d orbital involving hybridization also we will discuss. Clear? So in this case mainly third period elements. Clear? You know already in the periodic table. Third period elements. They contain 3D orbital in addition to s and p orbital. What is it here? S and p orbital. Clear? So if you see the energy difference between 3D orbital, the energy difference between 3D orbital to 3s and 3p orbital is very less. The energy of 3D orbital is comparable to the energy of 3s and 3p, and also the energy of 3D orbitals are comparable to the energy of 4s and 4p. So that's why these orbitals involved in the hybridization. Clear? So what it is here? The energy of which orbital here? 3D orbitals are what it is? Comparable to the energy of which orbital here? 3s and 3p orbitals. 3s and 3p orbitals. In the same way, the energy of 3D orbitals are comparable to the 4s and 4p orbitals also. Clear? So this means 3D, 3s, 3p and 3D, 4s, 4p orbitals will have almost similar energies. Means energies are almost equal, not equal, almost comparable we can say. So that's why, and in the hybridization 3D, 3s, 3p are 3D, 4s, 4p orbitals involves in hybridization. This is clear. We have types of hybridization: sp3 and sp3d and sp3d2, sp3d3. That all we will discuss. Clear? And the first one is one compound I will discuss. Two compounds we will discuss, and which involves the d orbital, s orbital and p orbital in hybridization. Clear? The first one is formation of formation of PCl5. What is the hybridization? sp3 dehybridization. Clear? This is. So we will discuss about this one. Clear? You know phosphorus. What is the ground state electronic configuration? Phosphorus is belongs to which group now? 15th group. So you know 3s2 and 3p. 3 means how many electrons are there in the 3s orbital? 2 electrons. And here p orbital, how many electrons are there here? This is 3s and here which one? 3p. Clear? So but phosphorus is forming how many bonds here? 5 bonds. 5 bonds means how many unpaired electrons should be present? 5 unpaired electrons, because those unpaired electrons only participate in the bond formation. So that's why here 3 unpaired electrons are there. So that's why next which orbital will come here? Next 3d orbital will come. 3d orbitals are empty here. This is which orbital? 3d orbitals. Clear here? Now if I write here phosphorus in excited state electronic configuration, then what will happen? One of these electron will enter into the 3d. Why they entered into the 3d? I already mentioned. 3d, 3s, 3p orbital will have comparable energies. Clear? And 3d, 4s, 4p orbitals also have comparable. What is it here? Comparable energies. So that's why. So this electron will jump from here to here. Which one here? That is in excited state. So one of these electron here, and this one electron, and the next one is what? Another one electrons. In d orbital 5, p orbital 3, and s orbital 1. Now how many electrons are there here? Total how many electrons are there? 5 unpaired electrons, and these 5 unpaired electrons involved in the hybridization. They are actually involved in the formation of covalent bond. First of all, what will happen? Directly they will not. Pure atomic orbital will not involved in the hybridization directly. Will not involve p orbital. You know, if you take this pure orbital involved in the overlapping, then I already mentioned. So orbital overlapping concept is failed. So that's why first what they will do. These atomic orbital combined and form which one? You know, hybrid orbital. How many atomic orbital combined here? 5. So that's why you will get 5, 1s, 3p, 1d. So that's why you will get what is one? sp3 5 sp3d orbitals we get, and these 5 sp3d orbitals involved in the which one here? Bond formation. With which one? With the chlorine. Clear? So that I can find. If you see in this case, so I have written here phosphorus excited state. Clear? So what is here? 3s is there, and here there is a 3p, and here which one is there? 3d. Clear? So here 1 and 2, 3, 4, 5. Now what happened here? These are which one? Hybrid orbital. How many hybrid orbital we have? 5 hybrid orbital. Now what will happen? Chlorine. Chlorine is having one unpaired electron because NS2, NP3. What is the chlorine electronic configuration? And here 2s2, 3s2, 3p5. 3s2, 3p5 means it is having one unpaired electron. This is what it is. 3s2. This is what it is. 3p5. This is what chlorine. Chlorine is having one unpaired electron. And you know 5 sp3 hybridized orbital are also each 5 sp3d hybridal also having one unpaired electron. So that's why chlorine gives one electron and form one bond, and another chlorine give one electron, make a bond. This is clear. So downward. This is chlorine, and here this is chlorine is giving electrons. Clear? And make a what it is one covalent bond. Then what you are getting one here? PCl5. What you are getting here? PCl5. Clear? And otherwise, I can write here phosphorus is there. Phosphorus. How many hybrid orbitals we have? 5 sp3 hybridized orbitals. I am not writing the small one here though. I am writing directly. These are 5 sp3 hybridized orbitals. Phosphorus is having how many sp3 hybridized orbitals? 5. So you know when it is 5 sp3 hybridized orbital, sp3d is there. What is the shape of the molecule? Trigonal, bipyramidal. This is the only. Now what happened? p orbital, empty p orbital of chlorine, and you know not empty orbital. Here unpaired electron is there in the one p orbital. You know this unpaired electron, and you know each these sp3 d hybridized orbitals are also having one unpaired electron, and these involved in the hybridization means overlapping bond formation. Clear? So here each sp3d hybridized orbitals are having one unpaired electron, means unpaired electron, and you know chlorine is also having off-filled orbitals. Off-filled what is here? p orbital, and these two overlap. This is p orbital of chlorine, and this is p orbital of chlorine, and this is another p orbital of chlorine, and this is. Clear? Clear? So here how many electrons will be there? There are 2 electrons because each sp3 hybridized orbital having 1 electron, and this chlorine is having 1 unpaired electron. So that's why what will form here? You will get here PCl5. These all are which one? Chlorine off-filled p. These will not involve because they are filled, and this is off-filled. Off-filled orbitals only involved in the overlapping. So that's why you will get what is here p and chlorine, and here what is chlorine, and here chlorine. There is a chlorine, and here chlorine. This is what we will call here trigonal. What is here? Trigonal bipyramidal. Clear? So what is the hybridization? What is the shape of this molecule? Trigonal bipyramidal. Clear? I already mentioned These we will call as the equatorial bonds, and these two we will call as the axial bonds. Axial bonds are longer than equatorial bonds. Clear? Why means I have already given a reason. What is the bond angle here? 120, and here bond angle is how much? 90. That all we have previous only discussed. And this is about the formation of what it is here? PCl 5. So next one is formation of SF6. What is the hybridization of SF6 sulfur atom in the SF6? sp3 due to hybridization. Same what we have discussed in the same we have to discuss. Sulfur. Sulfur, what is the ground state electronic configuration? Sulfur belongs to cis group, so that's why 3s2, 3p4, total 6 electrons are there or not? So here in the 3s orbitals, 2 electrons are there. In the p orbital, how many electrons are there? 4 electrons are there. So that's why next which orbital will come? Empty p orbital. This is p orbital, and next which orbital will fill? D orbital will fill. Clear? You already know how to the energies of orbitals. You already studied in the atomic structure. Clear? 3s, 3p, and 3d will come. Got my point? So in this case, you see, and here. How many bonds sulfur is forming? 6 bonds. 6 bonds means how many unpaired electrons should be present? 6 unpaired electrons should be present. But here how many are there? 2. 2 means sulfur can form how many bonds? 2 bonds only. But it is forming 6 bonds. So 6 unpaired electrons should be present here. Further one we have to write excited state. First one is first excited state. First excited state means what is one? One of these electron will jump here because I already said 3s, 3p, 3p orbitals are having almost comparable energy. So electron can jump. So that's why, and one of these electron, p electron, will jump into the which orbital? D orbitals. 5 d orbitals will be there. D orbital. Clear? But here how many unpaired electrons are there? 4 unpaired electrons are there. With the sulfur means sulfur can form how many bonds? 4 bonds only. But here sulfur is forming how many bonds? 6 bonds. So another excited state. Sulfur and second excited state. Second excited state means what? This electron will enter into the d orbital. Means here 1 and here what it is? 1, 2, 3 and here d orbital we have 5. Already one is there and one will come. Clear? So now these orbitals involved in the what it is here? Bond formation. Clear? First of all, they are. First it will form which orbitals? Hybrid orbital. First hybrid orbital will form. These hybrid orbitals involved in the overlapping to form a bond. Clear? First how many are there here? This is S and here what is P and D. How many are there? Yes, P3 and what is D2 because 2 electrons are there here. So how many orbitals are there? 1, 2, 3, 4, 5, 6. So you will get 6 sp3d2 hybrid orbitals, and each sp3 hybrid orbital is having one unpaired electron. So that's why, and these unpaired electrons involved in the bond formation overlapping with the of-filled electron, of-filled orbital of what is here? Fluorine. Fluorine you already know. What is the fluorine electronic configuration? 2s2 and 2p5. So what is the 2s2, 2p5? Here 1, 2 electrons are there, and here p orbital 1, 2, 3, 4, 5. This is one unpaired electron of-filled orbital. Here also of-filled hybrid orbitals. So they overlap and form a bond. That bond we will call as which bond? Covalent bond. So if 6 sp3d2 is there, then what is the shape? Octahedral. Suppose if I write here, this is sulfur. So after these are what it is? Hybrid orbitals. These are which orbitals here? Hybrid orbitals. Clear? So actually another small lobe should be there. I am not writing for convenience. And there is this is one orbital. This is one orbital. Clear? These are sp3d2 orbital. Each are having one unpaired electron, and each fluorine. How many fluorines involved here? 6 fluorine. Each fluorine is also having one of-filled p orbital, and these two will overlap because here also off-filled. Here also off-filled. These orbital involved in the overlapping and form a covalent bond. So here this is one fluorine. Fluorine, clear? Like this. this is clear. So these all are which one? P orbital of fluorine. These all are which one? P orbital of fluorine. So these orbital which one? sp3d2. So these orbital are which one? sp3d2. It is which orbital? P orbital. sp3d2 and p orbital overlapping. You will get a here one sigma bond. Here also one sigma bond. Each one will have how many electrons here? There are 2 electrons because fluorine is giving 1 electron. Already are there 1 electron in the sp3 hydrogen orbital. Sometimes they will ask. And what is the which orbital involved in the formation of S and F sigma bond? Means what we have to write now? This is what it is. sp3d2 and this is what it is now. P orbital. This overlapping. You are getting 1 sigma. So like this, all sigma bonds are formed by the overlapping of sp3d orbital of sulfur and p orbital of which one? Fluorine. This is belongs to which one? Sulfur. This is belongs to which one? Clear? So this is about, means if you write here structure, I will write in this way. Clear? So this is sulfur is in the center and these are how many are there here? 6 are there and about fluorine, and here there is about clear? So this is about what it is here. I already mentioned what is the bond angle and everything, and this is what it is here, octahedral. Because I mentioned what is the shape of hybrid orbital, that is the shape of the molecule also. Clear my guys? So hybrid orbital shape what I have written now. I have written octahedral, so that's why molecule shape also what is octahedral only. This is about the formation of what it is sp6 and which hybridization here? sp3 central atom hybridization is sp3d2. So here next one is on table I am giving here. So shape of molecule, hybridization, atomic orbital and example. So here first one is square planar. What is the hybridization here? dsp2. And how it will form, this we will discuss in the coordination compounds. Next chapter is there in the second year. There we will discuss how we will form this. Just remember, square planar means what is the hybridization? dsp2. So means here one s is there, 2 p are there, and one is d are there. You know the p orbitals. We have px, py, and pz orbital we have. And d orbitals what it is? D orbital we have 5. What is that one? dxy. dyz, dzx, dx square minus y square, and dz square. These are 5 orbitals we have. Which d orbital we need to want? That I have given here. Sometimes they are asking in the competitive examination. Very important. Clear? So dsp2 means 1 s orbital, 2 orbitals involved are px and py, and another orbital is dx square y square. Simple. This is y means it is a square planar. Square planar means what is the shape? This is the square planar. Clear? You know that sp2 means px and py. Means x axis is there, y axis is there here. Means remaining also, because it is a planar. Planar means next d also should have the which one? X and y coordinates only. So which is having which d orbital is having both the x and y coordinates, that is dx square minus y square. So that's why that d orbital will involve. Clear? So example is this, NiCN4 2 minus. Clear? Next one, trigonal bipyramidal. So what is the hybridization? sp3d. Clear? So means here all p orbitals, px, py, pz. Then which d orbital will involve? You know that in this one trigonal bipyramidal. Clear? This is clear. So now you know in this one 2 pyramids will be there. So first of all, px they form here. What is here? Trigonal bipyramidal, just if you assume. Then this is a planar. This is a what is planar. And now this should be what it is. This should be perpendicular to plane. Perpendicular to plane means which orbital I have to take. Here pz one orbital is there. Pz means okay, this is pz. Then another one perpendicular means which orbital I have to take. Z only. Z only it is perpendicular to what is x and y. So that's why I have to take which orbital here? G, that is square. In the same way octahedral sp3d2. And here sp3d2 means octahedral. You already know what is the shape of octahedral. This is one is a square, and here 2 pyramids. Clear? You know that it is a first square has to form. S orbital, Px and Py, and dx square and y square. These four will form a planar because it is a x and y, and here also what is x and y. So these four, 1, 2, 3, and dx square and y square will form what it is planar. And to this planar, perpendicular orbitals should become which one that is? Z is there. One is the pz. Pz means another one should be what is Z. That is Z. Like that we have to say. So pentagonal bipyramidal sp3 d3, and all here all 3p orbital and all dxy dyz and dzx orbital. Very important this is table. Why? Because sometimes they are asking in the competitive examination. So octahedral sp3 d2 orbital, which d orbital involved in the hybridization? That sometimes they are asking. Very important table. So next one is here predicting the hybridization of what it is here central atom. Predicting the hybridization of which one here central atom. Yeah. See. So I already mentioned. So which some molecules they will give. You have to find out the hybridization of central atom. If you know hybridization of central atom, I already mentioned what is the hybridization of central atom, and that is the hybridization. If you know the central atom, we can know the shape of the molecule. What is the shape of hybrid orbitals, and that is the shape of the molecule. Clear? You already know if it is hybridization, is central atom hybridization is sp linear, sp2 then trigonal, trigonal planar, sp3 tetrahedral. Clear? sp3 d2 diagram we have discussed. Like it means if you know the hybridization of the central atom, and we can easily predict the shape of the molecule also. Clear? So based for that one, we have some formula that is they have given in the textbook, but we have another one simple shortcut is there that I will discuss when we discuss about the competitive. Now I will follow simple formula what they have given. Clear it is? So they will give you some molecule, they will ask what is the hybridization of the central atom. Clear? So that we have to find out. And first one we have to calculate here, calculate number of hybrid orbitals. We have to calculate what is the number of hybrid orbitals. Clear? How to calculate this? I will mention here x. Clear? How to calculate number of hybrid orbitals? Clear? So that is we have one formula. X is equal to half into x is equal to what it is here? Half into number of valence electrons, number of valence electrons of which atom? Central atom. Number of valence electrons of central atom. Clear? Plus and here number of monovalent atoms surrounding central atom, surrounding what it is here central atom. Clear? Minus charge on cation. What is here? Charge on cation. Clear? Next plus charge on anion. Anion means which charge? Negative charge. Anion means which charge? Negative charge. Cation means which charge? Positive. Positive means what we will do? We will remove one electron, we will subtract one electron. If negative charge is there, and we will add one electron. And this is the formula to calculate what is number of hybrid orbitals. Number of hybrid, x is equal to what is one? Number of hybrid orbitals. And I will write in the simple way. Half into number of what is valence electrons plus what is here? Number of monovalent atoms and minus C and plus A. C means what is charge on cation and charge on anion. If monovalent atoms are not present, then we have to take here Ma is equal to 0. Monovalent means what? It should form only one bond. That is monovalent. If it is say, suppose oxygen is there, it is a which valent? Divalent. If chlorine is there, it is a which valent? Monovalent, 1 bond here and 2 bonds here. Clear? That is the formula. Yeah. And now, if you take x is equal to, suppose 2, if you got here, number of hydrogen atoms are 2, and here 3, 4, 5, 6, 7. This is what is here, number of hydrogen atoms. What is the hybridization? Hybridization. Clear one? So hybridization. Clear? What is the hybridization? And if you see 2 are there means sp. That is the hybridization. 1s and 1p. 1 plus 1 what is 1? 2. First of all you have to write s, and after that what you have to write p. P how many you can write? 3 only. P are plus how many? 1. 3 only. So yeah, 3. If you are getting number of hybrid aerosols are 3, then what is the hybridization? sp2. 2 plus 1 3. Then it is sp 3 plus 1 4. Next 3 are sp4 can we write? No. Why? Because 3 are done how many? 3 only. Next what it is man? sp3d, because next which orbital will start? D orbital. 3 plus 1 4. 4 plus 1 5. That is sp3 d2, and next one is what is man? sp3 d2. This is clear. So number of hybrid aerosols are 2. Then what is the hybridization? sp3, sp2, 4, sp3, 5, sp3d2, 5d, 6, sp3d2, 7. If you add all these 3 plus 3, 6 plus 1, 7, like that. And here you see, you need not to write s1 here. So that's why I am not writing 3 plus 2 plus 1, 6, like that. Clear? And here we can also calculate number of means lone pairs. What is here? How many lone pairs are there by using this formula? And the lone pair is equal to, what is here? Lone pair is equal to, and the number of hybrid orbitals, number of what is here? Number of means x, number of hybrid orbital minus number of hybrid orbital minus, clear one? So what it is here? Number of surrounding atoms. Number of what it is here? Surrounding atoms. So this is gives the what it is here? Number of lone pairs. So we will calculate how to do all these things, then we will get the clarity. Clear here? So this is about what it is, how to predict the hybridization. First we have to calculate number of hybrid orbitals by using this formula. V means valence electrons, and monovalence atoms are groups, and charge on cation plus charge on anion. This is the formula. If x value will get 2, 3, 4, 5, and corresponding hybridization is this. And how to calculate number of lone pairs? Number of hybrid orbitals minus number of surrounding atoms. If you do, then you will get how many lone pairs are there on the central atom. We can easily calculate. And I will do the example, then we will get that. So we will take some examples here, then we will calculate what is the hybridization of the central atom. Okay? First one I will take here, the compound is boron trifluoride. What is the compound here? Boron trifluoride. Now you have to calculate what is the hybridization of the central atom. What is the central atom here? Boron. What is the hybridization we have to calculate? First we have to calculate what is the number of hybrid orbitals. So x is equal to, for this compound, calculate what is the x. X is equal to half into valency electrons. What do you have to calculate here? Valency electron. Boron. Boron is a which group? 13th group or third group. Clear? So third group means how many valence electrons are there? 3. So you know that boron, and the next one is carbon, nitrogen, oxygen, fluorine, and neon. This is which group? Third group. Means 13th group, we will simply, if you don't consider the d orbital in the middle can be orbital, we will say third group. This is which one? Fourth, fifth, and here sixth, seventh, and here what is the eighth group. So what is the group? That is the valency. So what is the boron belongs to which group? Third group. So how many valence electrons it will have? 3 valence electrons. Or if you don't want to, if you don't know this is boron, you know what is the boron? 1s2, 2s2, and 2p1. Because boron atomic number how much? 5. Clear? You know valence electrons means you have to take outermost only. So 2 plus 1 how many? 3. So that's why. and 3 electrons. Plus, how many monovalent atoms are there? And fluorine forms how many bonds? One bond only. So that's why monovalent atoms how many are there? Yeah, 3. So 3 plus 1 3. Is there any charge on this molecule? Is it positive or negative? So no charge. So that's why charge on the cation is 0. Charge on the anion is also is equal to 0. So now x is equal to what you will get now? Half into 3 plus 3. 6. 6 means what is now? 3. 3 is there. What is the hybridization? First what you have to write? Yes, you have to write. Remaining what you have to write? P. P how many you have to write? 2. Because 2 plus 1, 3. What is the hybridization? Yes, P. 2 hybridization. So how many lone pair of electrons are there? How to calculate? I already mentioned number of hybrid orbital minus what it is now surrounding atoms. How many number of hybrid atoms we have? 3. How many surrounding atoms we have? 3. 3 minus 3 what is now? 0. So this molecule will not have any lone pairs. So this is the hybridization how to calculate. Okay? Suppose this is the first example. I will write here second example. CO2. For CO2 calculate hybridization, central atom is this. You know what is the shape structure of this molecule? This is oxygen is there. Oxygen is monovalent or divalent? Divalent. Why? Because oxygen forms how many bonds? 2 bonds. But we need what it is? Monovalent atoms. Monovalent atoms. So that's why calculate here x number of hybrid atoms of into carbon. We have to take central atom only. Hybridization means central atom means belongs to which one? The fourth group. Fourth group means how many valence electrons we will have? 4 valence electrons. If you don't know, just write the electronic configuration. So valence electron you take. Number of monovalent atoms. How many number of monovalent atoms are there? Monovalent atoms are there or here? No. These are which one? Divalent atoms. So that's why monovalent atoms are not there. 0. Is there any charge on this molecule? No. So cation charge is 0. Anion also there is no charge. So that's why I have to take like this. So then what you will get? And here I will get 4 only. Means 4 means what you will get? 2. 2 means what is the hybridization? Hybridization is equal to how much you will get? Yes, P. 1s, 1p. First you have to start with S, then P. So this is 1 plus 1, 2. And the lone pair calculate. How many lone pairs are there around the central atom? Lone pair formula what it is? Number of hybrid atoms minus surrounding atoms. Number of hybrid atoms how many? 2. How many surrounding atoms are there here? 2. 2 minus 2 what is 0. There is no lone pair. Clear? In the same way, I will write another molecule. So how easy this is to calculate? Another very easy method is there that I will discuss when we will discuss about the competitive shortcut method. Clear? If I discuss that method here, you will not follow this. You will follow that one only. But if they ask in the PU examination, you have to use this formula only. Clear? So NH4 plus is there. So what is the central atom here? Nitrogen. Why nitrogen? Because hydrogen cannot act as a central atom, because you know hydrogen will have only one electron, so it can form only one bond. But central atom should have the capability to form more than one bond. So that's why this cannot act as a what is here? Central atom. Calculate here x is equal to 1 by 2 into nitrogen. Nitrogen belongs to which group? 50 group. How many electrons will have? 5 plus how many monovalent? Hydrogen will form one bond only. So 4 monovalents are there. Charge on cation. This is positive charge is there. It is a positive charge means we will consider as a cation. Negative charge is there, we will consider as a anion. It is a positive charge cation minus 1. It is not a anion, 0. Clear? Then what you will get here? And you will get, and 5 minus 3 means 8 minus 1. 4 minus 1, 3 plus 5, 8. So what is it? 4. 4 means what is the hybridization? What is the hybridization of central atom? What is the hybridization of central atom? sp3 because 3 plus 1, 4. That is only hybridization. Is there any lone pair of electrons on the nitrogen atom? No lone pair. Why? Why? Because you see on the surrounding number of hybrid atoms are 4. Surrounding atoms are how many? 4. 0 lone pair. 1 by 1. In this way you have to calculate. And next one. If I write here NH3, what is the x value? X is equal to half into N5 plus monovalent 3. There is no charge. So that's why 0. So what it is? Half. 5 plus 3 how much? 8. 8 means what it is here? How many orbitals are there? 4. What is the hybridization? Hybridization is what it is here? sp3. sp3, but how many lone pairs are there? You have to calculate. Lone pair, how we will calculate? Number of hybrid electron minus surrounding atoms. How many are there? 3. 3 means what it is, ma? 1. One lone pair is there. One totally sp3. How many orbitals are there here? Hybrid orbital 4. In that one hybrid orbital occupies the lone pair. Means here 3 bond pairs. One lone pair is there. How many bonds are there here? 3 bonds. Nitrogen is forming 3 bonds. 3 bonds are there means it is a bond pair. 3 bond pairs and 1 lone pair. What is the shape? Pyramidal shape. That is. So what is the shape of this molecule here? You already know that. What is the shape? If it is having 3 bond pairs and 1 lone pair, then what is the shape? Shape is equal to pyramidal. What is here? Pyramidal. So in the same way, I have taken here. I will take another one compound with the negative charge. Clear? So I will write here CO3 2 minus. So what is the hybridization? You have to calculate. First of all, calculate the number of hydrogen. Carbon is a central atom. So half into valence electrons. How many? 4 minus 4 plus monoatomic atoms. Monovalent atoms. Oxygen, you know, divalent atoms. So that's why we cannot take 0. Is there? It is a anion or cation? It is a cation. So charge on the cation will be 0. It is not a cation, so we need not write any charge. Anion. Anion is how much mark? 2. Charge is how much mark? 2. So that's why you have to write that 2. Don't write minus 2 here. Charge on anion. What is the negative means anion. What is the charge? 2. That 2 you have to write. Clear? Then what you will get here? And you will get 4 plus what is here? 2. 4 plus 2 how much here? 6. 6 means what is here? 3. 3 means what is the hybridization? X is equal to 3 means what is the hybridization? Hybridization is, what is the hybridization here? sp3, sp2. This is the hybridization. Clear? So lone pair electrons 0 because 3 minus surrounding atoms also 3. So this is the way how to calculate the hybridization for given molecule or ion. This is homework we have to do. Clear? I already mentioned this. I have given 15 examples here. You have to calculate the hybridization. First of all, number of hybrid orbitals, hybridization, and lone pairs. Clear? So you already know how to calculate this. Use the formula. You know, silicon is there. Silicon belongs to which group? Fourth group. Carbon, silicon. You will get fourth group. Below the carbon, silicon, zirconium, tin, and lead. Clear? Phosphorus. Phosphorus belongs to what reason? Nitrogen and phosphorus. Nitrogen, phosphorus, arsenic, antimony, and bismuth. Phosphorus is belongs to which group? Fifth group. And you know, next iodine. Iodine means you know fluorine, chlorine, bromine, iodine. This is which group? Seventh group. And here also hydrogen and carbon, you already know. Nitrogen, you know, sulfur. Sulfur, oxygen, sulfur, selenium, tellurium, and polonium. Chlorine is belongs to this. So valence silicon is their valence electrons how many? 4. And phosphorus is their valence electrons how many? 5. Sulfur valence electrons 6. And iodine and chlorine valence electrons 7. That you have to use. And here I will say one example simple. How to calculate the hybridization. Clear? So we have discussed, and now how many bond pairs are there, how many lone pairs are there, how to calculate that. Clear? So that we will discuss later. For simple example for this, I will say C double bond O and C double bond O. Clear? I have calculated already. How many lone pairs I got? Lone pairs here is equal to 0. We have calculated that. Now bond pairs how many? Clear? Bond pairs means only we have to take the sigma bond only. Pi bond we should not consider. Clear? So here one is sigma, another one is pi. One is sigma, another one is pi. Clear? So but how many sigma bonds are there? 2 sigma bonds. So that's why bond pairs how many? 2 only. Got me one here? So bond pairs 2 are there. Then what is the, you already know. Bond pairs 2. Bond pairs 2. Lone pairs 0. What is the shape of molecule here? Linear. Like that. Clear? If I take any example here. Clear? So suppose NH3 if I take. NH3 means you already know what is the NH3. I have already calculated. Clear? Ma? So bond pairs, how many are there? How many bonds, sigma bonds are there? Hydrogen, I will write hydrogen, and hydrogen. How many bond pairs? Sigma. How many sigma bonds are there? Those are bond pairs. So how many are there? Sigma bonds are there. 3 bond pairs. We have calculated lone pairs for NH3. How many we got? 3 lone pairs. So 3 plus 1 total how much, ma? 4. These are 4 means what is the hybridization? sp3. This is hybridization. Number of bond pairs plus number of lone pairs is equal to number of hybrid electrons. That is what is the hybridization, sp3. If 3 bond pairs are there, 1 lone pair is there, what is the shape of that molecule? I have given already. In this way you have to calculate. But not don't confuse here. I already said I will give one very good trick. So that I will give in the competitive. While we are discussing in the competitive, I will give. But this is your homework to do. Calculate H value, hybridization, and number of bond pairs. Clear, my dears? So this is the homework for you. So here I will give the trick here only. So what is how to calculate easily hybridization and shape of the molecule. Clear? I will take one example. And here the first one is, but don't use this one in the PU examination. If they ask calculate the hybridization, means don't use this trick. Previous what I have given, x is equal to half valence electron plus monoatomic monovalent atoms minus C plus A. That only you use if they ask in the PU. So what is that one here? Another one is, if any molecules gives, then what is here? Suppose they have 3, they have 3. So calculate hybridization and shape of the molecule. Clear one? First of all, what you have to write? This is boron. Boron belongs to which group? Third group. How many valence electron it will have? 3 valence electrons. So right here there are 3 valence electrons. Which one? Boron. Boron is having how many valence electrons? 3 valence electrons. Now fluorine is there. Clear? Boron has to form how many bonds with the fluorine? Each fluorine 1 bond. 1 bond means fluorine will give 1 electron. Boron has to give 1 electron. So that's why here 3 fluorine atoms are there and 1 electron. This fluorine give 1 electron. Boron give 1 electron, 1 bond. Fluorine give 1 electron. Boron give 1 electron, 1 bond. And fluorine give 1 electron. Boron give 1 electron. Clear? So these will be called as a what it is here? Bond pairs. These all are which bonds here? Sigma bonds. So sigma bonds we will consider as a bond pairs. How many bond pairs are there? 3 bond pairs. Is there any lone pairs here? Means if any electrons are left here, then we will consider as a one pair. But no other electrons are there. 0 lone pair. How many lone pairs? 0. So 3 plus 0, 3. 3 means what is the hybridization? sp2. If 3 bond pairs and 0 lone pairs, what is the shape? Trigonal. Shape is what is here? Shape. Trigonal planar. Trigonal planar. This is. That is the simple one. You see how much easy. Next, means you must know what is the table. 3 bond pairs, 0 lone pairs, 4 bond pairs, 0 lone pairs, and 3 bond pairs, 1 lone pair. What is the shape? That you must know. Clear? Next one I will take here. NH3. NH3 means nitrogen. Nitrogen belongs to which group? No, 5th group. 5th group means how many electrons we have to write? 5 electrons we have to write. Clear? No? So right here 5 electrons. 1, 2, 3, 4, 5. Hydrogen. Hydrogen will form how many bonds? One single bond only. So one hydrogen give 1 electron. One nitrogen will give 1 electron. So that's why hydrogen. 3 bonds will form. Hydrogen give 1 electron. Nitrogen will give 1 electron. 1 bond. 1 bond. 1 bond. How many electrons are left? 2 electrons. These how many electrons are left, that we will take as a pair. Clear? So these are which bonds? Sigma bonds means how many bond pairs are there? 3 bond pairs. But how many lone pair is there? 1 only. Pair it is 1 lone pair. Clear? 3 plus 1 how much? 4. 4 hybrid electron. So what is the hybridization here? Hybridization. Hybridization is what it is here? Hybridization is sp3. 3 plus 1, 4. 3 bond pairs and lone pairs. What is the shape? Pyramidal shape. You see how easy this is. Clear? This is the simple trick. And in the same way, I will write here. Any molecule you take, we can easily calculate in this way. Suppose I will write here CO3 2 minus. CO3 what it is? 2 minus. You know 2 minus means minus is there. You have to add the electron. Plus is there. You have to remove the electron. You know the carbon. Carbon belongs to which group? 4th group. 4 valence electrons. How many will have? Carbon will have 4 valence electrons. And here what it is there? 2 minus. 2 minus means you have to add the 2 electrons. Add 2 electrons here. Got my point over here? If plus 2 is there, you have to remove 2 electrons. What is one? Total 6 electrons. You know oxygen. Oxygen forms how many bonds? Double bond means oxygen forms 2 bonds. It is a divalent, so it will form 2 bonds. 2 bonds means how many electrons a carbon should give? 2 electrons. Carbon give 1 electron. Oxygen give 1 electron. 1 bond will form. Carbon give another 1 electron. Oxygen give another electron. How many bonds? 2 bonds means 2 forming 2 bonds. Clear? No? 1 bond formation, 1 electron should give. 2 bond formation, 2 electrons should give. So here 1 oxygen is there. 1 oxygen will form how many bonds? 2 bonds. I will write very clear. Clear? So 2 bonds. Clear? So here also another oxygen. Oxygen forms how many bonds? 2 bonds. 2 bonds means carbon should give how many electrons? 2 electrons. Oxygen will form 2 bonds. 3 oxygens are there. I have written 3 electrons. Clear here? Now you know that oxygen form 1. You know oxygen is there. C double bond O, C double bond O. We have discussed. One is sigma, another one is pi. One is sigma, another one is pi. It is forming 2 bonds means one is sigma and another one is pi. One is sigma and another one is pi. But I already mentioned we have to take the which bond here? Sigma bond only. Got my point? Sigma bond. Pi bonds we never considered in the calculation of hybrid. I already said hybrid orbital never involved in the formation of pi bond. So that's why we have to consider only sigma bond. Sigma bond means what? One sigma bond means one bond pair. One bond pair. One 2 electrons here. One pair. So we have 3 bond pairs. Plus is there any lone pair here? No lone pair. 0 lone pair. You should not consider pi bond here. 3 sigma bonds are there means 3 bond pairs. 1 bond means how many electrons? 1, 2 electrons. 1 pair we will call, that we will call as a bond pair. Clear? No? So that is. So what is the 3 plus 0? 3. 3 means what is the hybridization? Hybridization is what is one here? sp2. 2 plus 1, 3. 3 plus 0. What is the shape? Shape of the molecule is trigonal planar. This is how to do. Clear? Another one I will write here. NH4 plus. NH4 plus. Nitrogen belongs to which group? 5th group. Right here 5 electrons. But here what is there? Plus 1 is there. Plus 1 means you have to remove 1 electron. Remove 1 electron, 4 electrons only. Clear, my now each hydrogen need 1 electron from the nitrogen to form a bond, sigma bond, single bond. So that's why how many bond pairs are there? These are bond pairs. So 4 bond pairs and 0 lone pair. So what is the hybrid? What is the total number of hybrid orbital? 4. What is the hybridization? Hybridization is equal to what is sp3. 4 plus 0 means what is the here shape? Tetrahedral. Clear? So that is it. If you take any example, suppose another example I will take XeF4 xenon tetrachloride. Take any example like this you can do. Xenon means belongs to which group? It is a 8th group. Noble gases. Noble gases means what is helium, neon, argon, krypton, and xenon. How many electrons you have to write? 8 electrons you have to write. Clear? 8 electrons. Fluorine forms 1 bond only. So each fluorine required 1 electron from the xenon to form a. Fluorine give 1 electron. Xenon should give 1 electron to form a bond. So how many electrons are left here? 4. 4 means you have to write those left electrons as a base. Clear? So 4 bonds are there. So that's why you have 4 bond pairs. And here how many lone pairs? 2 lone pairs. 2 plus 4, 6. What is the hybridization? Hybridization is what is one here? sp3. 3 plus 1, 4 and d3. d2. That is sp3. What is one here? d2. You know when 4 bond pairs and 2 lone pairs, what is the shape of molecule? Shape of molecule is a square planar. This is. You see what that is? Means you must read the table. And in the same way, SO4 2 minus ion. Take here, sulfur belongs to which group? 6 group. How many electrons I have to write? 6 electrons. But here 2 minus means I have to add 2 more electrons. Clear? Oxygen, you know, each oxygen forms how many bonds? Oxygen form here 2 bonds. One is the sigma and another one is pi. Sigma bond, pi bond, sigma bond, pi bond, sigma pi and sigma pi. But you should not consider pi bonds as a bond pairs. So sigma bonds only 1, 2, 3, 4. 4 bond pair. Is there any lone pair? 0 lone pair. So that's why 4. What is the hybridization? Hybridization is sp3. And what is the shape? 4 bond pairs and 0 lone pairs. What is the shape? Shape is tetrahedral shape. Tetrahedral shape. Clear? So this is how to calculate. This is simple trick for any molecule. If they give, you can use this trick to calculate the hybridization as well as shape of the molecule.